Okay. All right. So parametric functions in general are functions where the x and the y have their own rules. So instead of having one equation with the x and the y related to one another in it, so we're used to, bless you, we have instead a rule for x and a rule for y, and we have t, what we call is the parameter, and t is ultimately what we plug into these general functions. We plug t into a function to get y values, and we plug that same t into a different function to get x values, and the y and the x create, in most cases, a curve. We use this to graph curves that are maybe a little more difficult. We didn't do a whole lot in this class with conic sections, but conic sections refer to like parabolas and circles and hyperbolas and ellipses, and defining something with a parametric definition can maybe make it easier to graph those things. So we're going to kind of talk about number one first today, just how to graph a parametric function, and then we're mostly going to focus on parabolas, circles, and lines with parametrics, because those are functions that we practice already together. Okay, so this is an example of what a parametric equation is going to look like. So we have a definition for x in terms of t, the parameter. We have a definition for y in terms of t, the parameter. And then we have restrictions for t in this case. Sometimes you'll see negative infinity or infinity. It'll be defined for all real numbers. In this case, the values of t are going to be between -3 and 1. And it's equal to there, so we're going to use -3 and 1. If it wasn't equal to, we'd still plug them into our table, but we would end up having open circles instead of closed circles on our endpoints. Okay, so the first thing I'm going to do, you can just create 3 columns on your paper. So instead of just an XY table, we have a TXY table. T is going to be your input. X and Y are both outputs when we have a parametric equation. Okay. And we are going to use whatever t's it tells us to, in this case, -3 to 1. So I'll just count by ones, fill in my table. Okay. So now we're going to plug those values into both equations. So if I plug -3 into t squared minus 2, what do I get? We can do this in our head, hopefully. 9 minus 2, 7. If I plug -2 into t squared minus 2, I get 2. If I plug in -1, I get out -1. If I plug in 0, and if I plug in 1, I get out -1. Okay. Y, all I have to do is do 3 times my t value. So those will be quick. 3 times -3, -9, 2, -2 times 3, -6, -3, 0, and 3. Okay. Then, to graph, we're just going to graph our normal old xy's like we're used to. Okay, so t doesn't actually show up on the graph itself. It's just the values that we use to create these x and y's. All right, so 7, -9, you can just make a rough sketch on your paper. 2, -6, -1, -3, -2, 0, and -1, 3. Okay. And then that is the graph of our parametric equation. You can see it's not actually a function on its own with the x and y. It wouldn't pass the vertical line test, but the definitions for x and y are functions. So that's why we're allowed to call it a parametric equation. Okay. Again, if the intervals didn't have equal to, if it just said less than, we just put open circles on those endpoints instead. Any questions? Okay, great. All right, so now let's say we have an equation and a parametric equation, and we want to eliminate the parameter. If it says to eliminate the parameter, we want to be able to remove the t. That's the parameter. We want to just write an equation that only has x and y. This is going to look like substitution. Okay, so we're going to get a variable alone in one equation. Whatever it's equal to, we're going to plug that into the other equation and simplify. We've done stuff like that before. It is easiest to start with the x equation. The reason for that is because then I'm going to plug stuff into my y equation, and usually we want the y to be alone, so it's going to make my life a little bit easier at the end. Okay? All right, so if I want to eliminate the parameter, I'm going to start with the x equation, and I'm just going to get the t by itself. So how do I get, and if I have x equals 1 minus 2t, how am I going to get the t alone? Subtract 1, so x minus 1 equals negative 2t, and then divide by negative 2. So I'm going to write x over negative 2, and then if I do negative 1 over negative 2, it'll be positive 1/2 equals t. Okay, t's alone. Once you have it alone, whatever it's equal to, we're going to plug into the other equation, and that will eliminate the t and just leave me with an x and a y, which is what I want. So y equals 2 minus x over negative 2 plus 1/2. And then we simplify. If I have a negative next to parentheses, I know I'm going to distribute it. So I'll have a positive x over 2 minus 1/2. I can combine like terms. A positive 2 and a negative 1/2 gives me, you can say 3/2 or 1.5. And then you should be able to tell me what this is an equation of now. Kind of like we did with the polar equations. We got rid of the r's and the thetas before, and it was something we recognized. Now we get rid of the t's, and it's something we recognize. What is it? This is a line. And if it's a line, you should be able to tell me the slope and the y-intercept. What is the slope? 1/2. And what is the y-intercept? 3/2. Okay, so that's our answer. We eliminated the parameter, and then we identified and described the graph. Now, the t values that we were given there was negative infinity to infinity, which means this graph is a complete line. It's every possible value of t. So it would be the full line if we were to go ahead and graph it. It would have arrows on both sides. Make sense? Okay, now, this is the exact same question, so you don't have to write anything down, except this part. We're going to change the domain of t. Okay, so now it's restricted instead of being negative infinity to infinity. Now we just said this was a line, and the slope was 1/2, and the y-intercept was 3/2, and the equation, when we eliminated the parameter, was y equals 1/2 x plus 3/2. That's all the stuff you should have on your paper already. Now describing it, here's the difference. There's only certain values of this graph that are actually going to show up. And they're only on a line segment where t is defined between 2 and 6. So instead of a line, if t only goes between 2 and 6, it is now a line segment. Okay, that starts when t equals 2, and it ends when t equals 6. Okay, we need to figure out where that start and stop point are. The easiest way to do that is to just calculate the x and the y's when t is 2 and t is 6. So if I plug 2 into the x equation at the top, what do I get? I would do, if I plug it into the x equation up here, if I plug 2 in, 1 minus 2 times 2, what do I get? Negative 3. If I plug t into my y equation, what do I get? Get 0. So its actual endpoint on one side is negative 3, 0, because that's where the t starts. Okay, let's say I plug 6 into my x and y equation. If I plug 6 in, what do I get? negative 11. And if I plug 6 into 2 minus t, I get negative 4. That is the other end point of that line segment. Okay, so if it's negative infinity, infinity just goes on forever. If it's restricted, you just plug those numbers into your original parameters and decide where that means it's going to start and stop at. Okay. Really, you could just calculate the x's and then plug the x's into our line equation if you wanted to. That was another option. Any questions on that one? All right, let's do another one. Okay, so this time we're going to eliminate the parameter again. Figure out what kind of equation we've got. This one is again restricted, or not restricted, I guess, between negative infinity and infinity is where the parameter is defined. Okay, so I want to get my t alone, and I'm going to start with my x equation. So let's see, x plus 2 equals t squared. And then what do I do to get my t alone? Take the square root. So we're going to say plus and minus square root of x plus 2 equals t. Okay, now I'm going to take that and I'm going to plug it in over here. Y equals 3 times the square root of, and technically it's plus or minus, x plus 2. Okay, so this, if you don't recognize it, do you guys remember what the square root equation looks like? It's like half of a parabola on its side. Remember that from last semester? Like has a starting point and then it kind of curves up into the side. This one is going to have a vertex or an end point at negative 2, 0. That 0 comes from there's nothing added on the outside. It's just like what we do with our parabolas. The opposite of the number inside, the number on the outside. So at negative 2, 0, I'm going to start, and then because of the plus or minus, we're going to have a curve going up, and we're going to have a curve going down. And that's it. So what is this a picture of? What do we have? Parabola? Which way is it opening? We haven't seen a lot of these in this class. Opening. It's not up or down, right? It's open to the right. Okay, a little weird, but it's an interesting picture. Okay, so that's what it would look like if you eliminate the parameter and you have something this square. You end up with a parabola in it. Any questions? Moving on. Okay, let's look at this one. That's a 0 to 2 pi. I don't know why my pi looks like that. That's 0 to 2 pi, that's that. So the reason we don't have negative infinity now, we have 0 to 2 pi's, because now we're talking about trig functions. So if we're trying between 0 and 2 pi, we have a full rotations covering every value. So this is essentially the negative infinity option. Okay. Now this one, I can get t alone, but it's a little gross with the inverse functions. So what we're going to do instead, to make our life easier, is we're going to square both equations, and we're going to square both sides. And there's no plus or minus, so we're just allowed to distribute that squared right through. So it's going to look like x squared equals, if I do 2 squared, I get 4. Cosine squared is cosine squared. And then same thing with y. Y squared equals 4 sine squared. Okay. Now what we're going to do is we are going to add these equations together. Okay, just like it's a system of equations. I'm going to add what's on the left together, and I'm going to add what's on the right together. X squared plus y squared is what's on the left. And on the right, I have 4 cosine squared plus 4 sine squared. Now look at what I have on that right side. What do you notice? A 4 is in both the terms. Factor it out. And if I factor that 4 out, I'm left with cosine squared plus sine squared. What is cosine squared plus sine squared? It's 1. So essentially it's going to go away. So I am left with the equation x squared plus y squared equals 4. You should be able to tell me what that is. It's a circle. And to describe the circle, you should be able to tell me its center and its radius. Center is 0, 0. Radius is 2. Okay? Any questions? Okay, that might be where we're going to stop today. Hold on. Yes, so tomorrow then we'll do the second half of the lesson where we're going to write parametric equations for lines and circles, and that'll finish it up. I'm going to give you guys the homework. This is going to be graded kind of like the worksheets that we did with the trade proofs, where there were like 2 or 3 depicts and graded for correctness, and then everything else was graded for completion. Okay? I'll tell you which ones you can do now if you want to get started on it. I believe this was due on Monday. Let me double check that deadline real quick. 4, 5. There you go. Yes, this is due on Monday when you come into class. You guys should be able to do, let's see here. Everything up through number 5, you should be able to do the first half of it. Okay? So you guys can start on that for the rest of the period. Tomorrow we'll finish up the lesson. And then starting on Friday, actually you could work on this a little bit if you wanted to, but I'm going to get you guys exam review stuff on Friday, then we'll start looking forward to that. Okay?